Welcome to the part 2 of this lesson. So let's read the instruction first. A pot with water is placed on a burner. Drop 4 to 5 small plastic buttons in it and observe their movement in water. Okay, so after dropping 4 to 5 small plastic button, what do we observe? It's written here in the explanation. Water expands on heating. The hot water from the base move upwards. With it, the buttons too are pushed to the surface. The relatively cooler water in the upper portion move downwards, taking the buttons with it. This happens repeatedly. In other words, on heating, an upward current sets in the water. In nature, the conditions are slightly different. Okay, what it means? इसका ये मतलब होता है कि जब पानी गर्म करते हैं हम, तो पानी का जो बेस होता है डाउनवर्ड्स, ओके, सरफेस में जो पानी होता है यहाँ पर वो गर्म होकर ऊपर की तरफ जाता है, और जो ऊपर की तरफ पानी होता है जो अभी गर्म नहीं हुआ है वो नीचे की तरफ आता है. ओके, और ये प्रोसेस कंटिन्यूसली होते रहता है, और जब ये प्रोसेस कंटिन्यूसली होते रहता है उस प्रोसेस में जो बटन्स है ऊपर, ओके, वो भी नीचे की तरफ आती है. ओके, सो गर्म पानी नीचे से ऊपर की तरफ जाता है और जो ठंडा पानी होता है वो ऊपर से नीचे की तरफ आता है और अपने साथ बटन्स को भी लेकर आता है. Okay, so it means that the hot water which is at the base move upwards. Okay, and when the hot water moves upward, it will push the cold water downwards, and with that the buttons which are at the top layer, at the upper layer, that move downwards as well. Okay, so this process continuously happens. And in nature the conditions are slightly different. So somewhat it is similar in nature, but there is slight difference as well. We will learn what is the difference. Okay, due to temperature differences, both upward and horizontal current develop in the ocean. Upward and horizontal, it means horizontal, you know this. Upward means vertical. So it's saying that horizontal and vertical both kind of current develop in the water. But what we have seen in this, that the current, it was the movement which you see happens. Okay, that current which we saw was down to up and up to down. But in nature, how it is formed? In nature it's horizontal and vertical. So and what is ocean current? Ocean current is a movement of sea water. Like if you have gone to any beach or sea, when you see far away, you will feel the water is continuously moving. Okay, so if anything is moving, okay, it requires an energy, anything, maybe air or something. So this water has a force or energy which we call as an ocean current. Okay, so it says that ocean current flow from the equator, you know, where the sun rays are perpendicular. Okay, so the equatorial area will be hot. Suppose then it's going towards the polar region. Polar region is a cold region. Okay, and again from the cold region it is moving towards the hot region. Okay, so I hope you understand. Equator to the polar region and polar region to the equator. Let's see. When an ocean current flows from the frigid to the torrid zone, frigid, again, frigid and polar region are same. Frigid means cold region, okay, where there is snowfall, and torrid zone means that particular area where sun rays are perpendicular, the area which is near to equator. Okay, so ocean current flows from the cold region to the hot region, and so when it goes from the cold region to the hot region, it reduces the temperature of the coast in the torrid zone. So it reduces the temperature of the hot region, okay, when the cold currents are moving towards the hot region. And same thing happens when a current flows from the torrid to the frigid zone. So when a current flows from the hot region to the cold region, it increases the temperature of the coast in the frigid zone. So it increases the temperature of the cold region. It means it makes the cold region little warmer. Okay, all right. So वो जो ठंडा रीजन होता है वहाँ पर जब हॉट करंट्स आते हैं उस वक्त वो उस हॉट करंट की वजह से थोड़ी सी वार्मर हो जाती है, एटमॉस्फेयर थोड़ा सा गर्म हो जाता है. Okay, okay, you can see here this pink line will tell you about the warm current and the blue line will tell you about the cold current. So let's see here. If you compare the northern hemisphere and the southern hemisphere, you will find that in northern hemisphere, okay, which is here, and the southern hemisphere, you will find that in northern hemisphere there are more pink lines as compared to the southern hemisphere. It means there are more warm current activity which take place in northern hemisphere as compared to south. And why is that? Because if you see that southern hemisphere is mostly covered with ocean. This blue part which you see here, these are all oceans. Okay, so where if you see the northern hemisphere, the major part of land is in northern hemisphere, okay, as compared to the southern hemisphere. In southern hemisphere we have some part of South America, Australia, Antarctica. Okay, so yes, let's read further. The regions where warm and cold current converge are favorable for the growth of planktons. Planktons are the food for fishes. Fish from other area travel towards this area in large numbers. They breed in warm water. Due to high concentration of fish population, fisheries thrive well in this area. So wherever you find this creature, okay, which is called plankton, okay, at that particular place fish will be attracted because these are kind of a favorite food for fish. Okay, and because of that particular area is rich in fisheries. Fisheries will thrive well in such areas. So we will see in the map where is such area. Okay, so you can see here, see Kuroshio current. Okay, it is a warm current which is going from south towards the north, and the one which is coming from north towards south, it's a cold current. Okay, you can see it's in blue color, so it's cold current. So when this warm and cold current merge, okay, there is a fog which is produced in that area. So there is fog produced in this area because of which plankton, okay, this creature grows there and fish are attracted. So there is such place in Japan. Okay, so this particular place is in Japan. So Japan have one of the largest fish industry because of such condition. Okay, that so it's written here that isotherms are lines that connect places with the same temperature after avoiding the effect of height. So it's a line which is drawn in this map, or you can see in this globe. Okay, you can see this pink line here. This is isotherm, and this line generally appear parallel to the latitude on world map. We will not say exact parallel, but it generally appears parallel, because you can see this is equator, so it's actually kind of parallel, but not a straight parallel. It's little towards upwards, then it goes downward, so we will call it generally parallel. Okay, observe the isotherm of 25 degrees Celsius in the map. This line occupies area close to the equator. The shape of this line appears like an ellipse on the map. Okay, the north-south spread of this ellipse is greater on the continent as compared to the oceans. Okay, so let's see. Okay, as per the instruction, let's find the 25 degrees Celsius in this map. So if you can see here, it's 25 degree here and 25 degree here. Now we will join. Okay, now if you see this pink line which pass through 25, okay, this line looks like an ellipse. Okay, so it looks like an ellipse, and the major part of this, it passes through the northern hemisphere, and the lesser part pass through the southern hemisphere. It's because in southern hemisphere you can see all in blue color. Okay, this is in southern hemisphere the major part is covered by oceans. Okay, all this part is an ocean, and there are 3 continents, some part of South America, some part of Africa, some part of Australia, and Antarctica. So these are the continents in southern hemisphere, but at northern hemisphere the continents are comparatively larger, so there are larger part of land in the northern hemisphere. Okay, so that's the reason the major part passes through the northern hemisphere. Okay, I'm reading the further instruction. It says you डिग्री को आप अगर ध्यान से देखें वो ऑलमोस्ट पैरेलल है. ओके, वो ऑलमोस्ट पैरेलल है इक्वेटर से यानी लैटिट्यूड से, बट सेम चीज़ अगर आप कंपेयर करें नॉर्दर्न हेमिस्फीयर में. ओके, सो 0 डिग्री यहाँ पे नॉर्दर्न हेमिस्फीयर का, इट इज़ स्ट्रेट. ओके, यहाँ तक स्ट्रेट है, वेस्ट में स्ट्रेट है, बट जैसे नॉर्थ अमेरिका में आ रहा है, नॉर्थ अमेरिका में क्या है, लैंड है, जैसे ओशन की तरफ था. ओके, पैसिफिक ओशन में वेस्ट की तरफ स्ट्रेट था, जैसे लैंड एरिया आया वैसे बेंड हो गया. ओके, वैसे बेंड हो गया. अब 0 डिग्री यहाँ से फिर से ओशन के यहाँ पे आपको स्ट्रेट लग रहा है, और जैसे लैंड एरिया आया वैसे फिर से बेंड हो गया. तो सिर्फ 0 डिग्री बेंड नहीं हो रहा, यहाँ पे जितने भी आइसोथर्म्स हैं नीचे की तरफ, ओके, वो काफ़ी हद तक जब ओशन से लैंड की तरफ आ रहे हैं तो बेंड हो रहे हैं. ओके, सो यस, और बेंड होकर वो कौन से कॉन्टिनेंट में, यूरेशिया यानी यूरोप और एशिया से वो गुज़र रहा है, यूरोप और एशिया से गुज़र रहा है. उसके बाद अगेन जैसे ओशन की तरफ है आया वैसे स्ट्रेट, सो ईस्ट में अगेन स्ट्रेट हो गया है, और ऐसे ही कुछ हद तक वो वहाँ से साउथ ईस्ट के तरफ नीचे की तरफ ट्रेवल करता है. ओके, सो यही बताने की कोशिश की गई है. सो लेट्स रीड. सो इससे हम यू विल फाइंड 2 isotherm with a label of 0 degree Celsius. Let's see that. I hope you can see the 0 degree isotherm in the northern and southern hemisphere both. Okay, the 0 degree Celsius isotherm from the southern hemisphere is largely straight and is parallel to the line of latitude. It means let's see the map. It is trying to say that the 0 degree, okay, I'm drawing line if you can see. So the 0 degree is largely parallel, not exactly parallel, but it's largely parallel. But if you see the 0 degree one, which is here, which is in northern hemisphere, it is not that parallel. Okay, so we will read further and understand. Comparatively, the line of the same value in the northern hemisphere deviates north and south considerably. In the west, in parts of the Pacific Ocean, it is fairly straight. Let's see that. So it is saying that in west, here, it is fairly straight, okay? But when it enters the continent of North America, it turns somewhat to the north. Then the line proceeds eastwards. Within a short distance, after entering the Atlantic Ocean, it turns towards the northeast. So it's trying to say that it's straight in the west, okay, but when it touches the land area in North America, it bends a little, okay. Then in ocean, it passes through the ocean. Then again when it touches the land area of Eurasia, which is Europe and Asia, it bends again. It bends because there is warm current present in the land area, and in ocean area is mostly cold currents, okay. So yes, and then when it touches the ocean again, okay, then it is straight towards the northeast, and from northeast it's kind of, you can say it's going to towards the southeast as well. Okay, this I have explained earlier, that the isotherm in the southern hemisphere are fairly parallel to the latitudinal line, because major part of southern hemisphere is covered with water. Okay, so from south pole to the tropic of Capricorn, the distance between this line is almost equal. Let's see that. So from south pole, from here till the tropic of Capricorn, till here, it is almost parallel. Okay, it is not exact parallel, but it's almost parallel. That's what it's trying to say. As the proportion of land in the southern hemisphere is limited, yes, there are limited land in some southern hemisphere as compared to the northern hemisphere. Temperature in this part are largely influenced by latitude. In the northern hemisphere, the distance between this line varies. We've already seen that it bends a lot towards northern hemisphere. In this hemisphere, the proportion of land is comparatively greater. This affects the distribution of temperature. Yes, there are proportion of land is greater in northern hemisphere. This effect are seen in the form of variation in the distance between the isotherms and curved nature of this line. So when we see the isotherms which are drawn on the globe, we see variation, a lot of variation in northern hemisphere, because there are a lot of land. The proportion of land area is larger, is greater in northern hemisphere. Okay. Different types of thermometers are used for measuring the temperature of air. Okay, mercury or alcohol is used in the thermometer. So I'll show you the thermometer here. You can see it's written here. You can see it's written here mercury or alcohol. So this red line which you see here, okay, this is the mercury or alcohol added in the thermometer. The freezing point of mercury is minus 39 degrees Celsius, where that of alcohol is 130 degrees Celsius. So you must have seen that, in movies, that whenever the shopkeeper or open the fridge and take the alcohol out, the alcohol is not frozen, okay, because it gets frozen at 130 degrees Celsius. Most of the time the alcohol is not frozen, whenever people buy alcohol from any shop. But in the case of mercury, it requires just 39 degrees Celsius to freeze. So mercury can freeze very earlier as compared to the alcohol. Alcohol takes a lot of time to be frozen. Okay. These materials are highly sensitive to temperature variation. Okay, so it's highly sensitive. That's the reason mercury and alcohol is used in thermometer to find out the temperature. Therefore, variation in temperature from 30 degrees Celsius to plus 55 degrees Celsius can easily be observed with the help of this material. Okay, the unit of measuring temperature are degree Celsius or degree Fahrenheit. So Celsius was the name, the last name of the person who invented this, and Fahrenheit is the name, last name of the person who invented the technique of Fahrenheit. Okay, as shown in this figure, these are expressed as Celsius is expressed as degree C and Fahrenheit as degree F. The difference in daily temperature, maximum, minimum, can be observed with the help of thermometer. Air temperature is measured in Celsius. Okay, so if we want to check the air temperature, we measure it in Celsius. Okay, that's it. That was the end of the lesson. I hope you understood.